Hello everyone. In this video, I want to talk about the order of elements in a group. This is the definition of the order of elements. It says that for a group G, and we look at any element X in G, then we can define the order of this element X to be the smallest positive integer n, such that x to n equals to 1. And we denote this integer by this format, which you have two bars on both sides of the element x, which is the same notation as the absolute value. But the idea is totally different. Then, in this case, we can call the x is to be of order n. Here, from the definition, we can see that the order of the element n should first to be a positive integer. And then it should be the smallest such positive integer to satisfy the property x to n equals to 1. Here, this equation and this format is actually based on the assumption that the group G we have here is a group G under the multiplication operation, because this x to n actually means you have x multiply x multiply x multiply a lot of x. How many of them? There are n x's in this sequence of multiplications, and the result is 1, and 1 is the identity element in this group G under the multiplication operation. But if we consider the group is under the addition operation, then the property will have a different form. It should look like this: n times x equals to 0. And this means nx just equal to x plus x plus x plus x, and there are n x's in this a lot of additions, and the result is 0, and 0 is the identity element in a group under addition. So you can see the property will have different form if you have different operations in a group, but the idea is the same. You just have like multiple elements in the operation, and you do the operation for like actually n minus 1 times, then the result is equals to the identity element in the group. Then the n satisfies this property, and if the n is the smallest such number, then smallest positive integer, then you say n is the order of this element x. So this is the definition of order of x. Let's look at an example. It will help you to understand it better. So a good example is the group Z3. Z3 is the group defined like this. The set is a set of 3 numbers, 0, 1, and 2. And the operation is the addition mod 3. The mod 3 addition means you do the addition between over 2 numbers, then the result should be in mod 3. For example, if you do 2 plus 2 mod 3, it means like in in the normal addition you get 4, but here if you are using this mod 3 addition, you need to consider the result in mod 3, which is the remainder. You divide 4 by this 3, and 4 divided 3 just equals to 1, and the remainder is 1. So this remainder is the final result here. So we get 2 plus 2 mod 3 actually equals to 1. And this group is defined like this. Now we can look at the order of its elements. So first, what is the order of 0? The order of 0 is just a 1. That is because this here we are using the addition notation, so we can consider 1 times 0 equals to, this means you have only 1 0 here to do the operation, so the result is 0 itself, and 0 is the identity, so we automatically satisfies this property here, and this n just 1 here, so it means the order of 0 is 1. And here we should note that this 1 is not an element in this group Z3, although we have 1 here as well, but the idea is different because we don't have the multiplication operation in this group. We only have the addition here, so this is just a format to show that how many zeros will you use in the additions. For example, if we use like 3 times 0, this 3 is not an element in this Z3, but this is still a legit format, and it just means you have 3 zeros here, and then you do the operation for them. So just be careful, this first number is not an element in the group. Okay, then we can talk about the order of 1 in the group. That is, we can try the positive integers 1 by 1 to find the smallest one to satisfy the property here. So at first we can consider the smallest positive integer, which is 1. Is the order of 1 is 1. We can check 1 times 1, just we have 1 here to do the addition, but 1 is not equal to 0, which is the identity, so we cannot say the order of 1 is 1. How about 2? If we consider 2, it means 2 times 1 should equal to the identity 0, but 2 times 1 means you have 2 1s here to do the addition, which is equal to 2, and 2 is not the identity in the Z3, so 2 is not the order of 1. How about 3? 3, if the order of 1 is 3, it means 3 times 1 should equal to 0, and here 3 times 1 equals to 1 plus 1 plus 1, and this equals to 3 mod 3. 3 mod 3 means you divide 3 by 3, and you get the remainder, and we know the remainder should be 0, so we get 3 times 1 equals to the identity, so 3 here, the 3 is the smallest positive integer, satisfies the property we want. So we say the order of 1 is 3. Similarly, the order of 2 can be found with the same steps. Is it 1? No, because 1 times 2 is just 2. It's not equal to 0. How about 2? 2 is 2 times 2. This is actually 4 module 3, which is equals to 1, not 0. So 1 and 2 are both not the order of 2. And the 3 means 3 times 2 equals to 6 modulo 3 equals 0. And because 6 divided by 3 equals 2, and the remainder is 0. So here we satisfy the property, and 3 is the order of 2. Okay, this is the definition and the example about the order of elements in a group. But there is an exception here. It says if you cannot find any positive power for x to satisfy this property, then we say that the order of x is defined to be infinity, and x is said to be infinite order. So it means basically if you cannot find any positive integer to satisfy this property, you just say n is infinity. We can look at an example. For example, if we look at the group, the set is R to the cross, and under the multiplication operation, here this R cross means the real numbers exclude 0. The reason is because we know from the definition of groups, every element in a group should have an inverse element, but 0 does not have inverse element when you consider the multiplication operation, because that is like you divide a number by 0, and that is not good. That is not well defined. So we can exclude 0, then the rest of number can all have inverse number, and they can be elements of the group. So in this group, if we consider maybe 2, then what is the order of 2? So because here we are using the multiplication notation, so we want to find n, smallest positive integer n, such as 2n equals to 1, which 1 is the identity element under the multiplication. But we know in real numbers, you don't have any like a positive integer power of 2 equals to 1. So this never true for any positive integer n. So no such n in positive integers. So in this case, we say the order of 2 is infinity. And this is just the exception we have in the end of the definition. Okay, that's all about the order of group elements, and see you next video.